Hi, I am Syed Rashid. You are watching Allahabad School and Junior College YouTube channel. Welcome to my video to all students as well as viewers. Today just we are continuing our class like intermediate second year physics, chapter number 4, electric charge and fields. Our today's topic is nothing but electric flux. What is electric flux? Electric flux is defined as the number of line of electric force passing perpendicularly through a given surface. That means if we are considering one surface here, okay, isn't it? So the lines which are passes perpendicular to these surfaces is nothing, okay. Electric flux is defined as the number of line passes, okay, of the electric force. This is an force, electric force line which is passes perpendicularly through a given surface. So let the surface is like A, B, C, D we can consider, okay. It is represented by the simple phi, okay. Electric flux is an scalar and it has a unit of Nm square by C. Here we can say like Newton meter by C. So this is the electric flux. Now one more topic we have with us is nothing but Gauss law of electricity, and this is one of the important law. It might not leave you until if you are looking for BSc physics or engineering physics also, this law will not going to leave you. What is Gauss law and what are its important, okay. According to the Gauss law, the total electric flux through any closed surface is equal to 1 by epsilon naught, okay. 1 by, this is a symbol like epsilon, we can call it as epsilon, times the net charge enclosed by that surface. That means if the electric flux through any closed surface, this is a closed surface and electric flux is, what is electric flux then? So this electric flux is nothing but, already I defined just now, you can see. So this law is given by 1 by epsilon naught. So here the complete law is like integration of epsilon naught, the part of E ds is equals to 1 by epsilon naught. This is the Gauss law of, we can say this Gauss law related to the electrostatic, okay. The importance of this Gauss law is nothing but, we have many things. First of all, this Gauss law is apply for any closed surfaces, whatever it may have shape, either size or any shape and size, whatever, there is no concern with shape and size, it is applicable for all closed surfaces. And the point number 3 is, Gauss law holds good for a charge which is at staying or stationary, or also for moving charges. This Gauss law is applicable for both the cases, either it may have stationary charges or it has moving charge, okay. Gauss law offer useful to simplify calculations of the electrostatic field for the symmetrical system. If we have one system like symmetrical system, this law is valid to calculate the simplification related to that. So this Gauss law and is important, might ask you in 4 marks. I am placing on the screen as you can see. Hope you have saw the Gauss law and it's important. Make sure you need to write and remember this answer also. Now we are doing one more topic with us like expression. This is related to something, the intensity of electric field at a point on the axial plane of and dipole. So this question and answer I will going to just place once I explain this, okay. This is dipole. What is dipole? All the student and viewers, we know that consider an electric dipole with 2 points like plus q and minus q separated by a distance like 2a. And what is dipole? All the student and viewers, we know that dipole is nothing but combination of positive and negative charge, okay. Now assume a point on the axial, we are driving this as axial plane. So consider this is an point with us and this point is nothing but P, okay, and this is an axial plane, okay, separated by a distance r from the center of dipole on the sides of charges q, both the q's. That means from here to here we have distance with us like r, okay. This is nothing but r, okay, from here to here r. So now the electric field intensity on P due to the minus is given as. Now you can see this is an unit positive charge, and the negative charge will be coming towards the positive charge. We can consider this as E minus Q, whereas the positive charge will be repelled and move away from the positive charge plus Q, that is E plus Q. So for E minus Q, what will be the value? I am going to write here E, okay, minus Q is equals to like minus Q by 4 pi epsilon naught R plus A whole square. From where we got this thing, and here we are considering one point, miss, it will be like P cap. From Coulomb's inverse law we got like this F is equals to nothing but we have one answer with us like Q1 Q2 by 4 pi epsilon naught into R square. Okay, here Q1 and Q2 we are considering as minus Q itself, and 4 pi is 4 pi as it is, epsilon naught is also as it is. In place of R square we are taking R plus A whole square. Why R plus A whole square? From like this distance R for negative E minus is nothing but this only. Okay, the electric field intensity on P due to the charge plus Q is given as, it will be given simply like E plus Q is equals to Q by 4 pi epsilon naught R minus A whole square, isn't it? P cap. Now the total electric field intensity at point P is E resultant, that is total is equals to E plus Q plus E minus Q. So same we have to consider E is equals to, like what is E plus Q? We have with us Q by 4 pi epsilon naught R minus A whole square. Now what is E minus? Here minus Q by 4 pi epsilon naught R plus A whole square P cap. Here also P cap. Now we are taking few things common in that. We can take simply common like Q by 4 pi epsilon naught P cap as common. So I am taking like Q by 4 pi epsilon naught common. Okay, I may remain like 1 by R minus A whole square minus 1 by R plus A whole square, and here also I am taking P cap common. Okay, so now we need to simplify this so that we will get the answer. Here Q by 4 pi epsilon naught as it is, whereas this will be going to cross multiply, isn't it? It will become R plus A whole square minus R minus A whole square. Okay, by like we can say R minus A whole square into R plus A whole square. This calculation is very, now all the student and viewers, if we want to solve this thing, we have two main like parts. We can say one part is we need to understand this diagram and we need to just the fetch the value of E like minus Q, that is negative charge, and E positive charge. If we remember to do these two things and the diagram is, we can do all the thing by our simple own calculation. Okay, now it will become, this is Q by 4 pi epsilon naught. Okay, now here we need to apply formulas, different algebraic formulas like A plus B whole square, A minus B whole square. From the formulas we will get this as R square plus A square plus 2AR, and from here we will get like R square plus A square minus 2AR, isn't it? How we got this? From the formula. I want to write the formula also. Here A plus B whole square is nothing but A square plus B square plus 2AB, and A minus B whole square is nothing but A square plus B square minus 2AB, isn't it? From that formulas only we will get these two steps. Same thing we need to do here also, like R square plus A square minus 2AR, isn't it? Here R square plus A square plus 2AR. Why? Because this is R minus A whole square, that means R square A square minus 2AR. Here R square A square plus 2AR, 2AB. Here 2 is 2 itself. In place of A we can say like, okay, AR also you can write or RA also you can write, it's your wish. So because it is in the if we want sequence means we need to write RA itself. So I am changing this AR into RA, isn't it? I want sequence, so it will be 2RA, we can say 2RA. So here you can see a difference between numerator and denominator. In numerator we can just open the bracket with the help of minus, but in denominator we need to multiply each and every term and we will get a big step with us. So for that first I will you have to first multiply this R to this R to like this R again to this, and this R to this again, and this A to this A to this, and this to this. So I will going to solve these steps, or else I can directly write also. So here it will become like Q by 4 pi epsilon naught, okay, R square plus A square plus 2RA. Here minus into plus minus, minus R square minus A square plus 2RA, isn't it? This is where our numerator, whereas denominator is nothing but R square into R square, it will become like R power 4, R square into A square, it will become R square, okay, A square, then R square into 2RA, it will become like plus 2R cube A, isn't it? And next term I will going to write with different color marker. A square into R square, it will become like A square R square, A square into A square, it will become like A power 4, okay, A square into 2RA, it will become 2RA cube, isn't it? Sir, you are watching on board, you are not watching to us. This is a max calculation, so I am doing like this. Then this next step, minus 2RA into R square, it will be like minus 2R cube A, isn't it? Next, minus 2RA into A square, it will be like minus 2RA cube, okay. This minus into minus become minus itself, minus 4RA, not 4RA, 4R square A square. So this is the step for like denominator. We have this thing, you can copy down these steps, because once I place the like derivation from respective material, you may not get this like complete solution part. It will going to write from this step to finally we will get one more step. So you need to write this roughly. Hope you have copied roughly. Now the next step you can see here, okay, plus R minus R get cancel, plus A minus A get cancel. Here you can see like minus 2R cube A plus 2R cube A get cancel, okay, plus 2R A cube minus 2R A cube get cancel. This and this will going to sum. Next step how I am writing, you can see, and this will also going to be in sum. So it will become like we can say E is equals to Q by 4 pi epsilon naught. Here we need to write finally like P cap, isn't it? So we will get like 4RA by, like here we have R power 4, okay, plus A power 4 plus R square A square minus 4R square A square, P cap. So we got this step with us. Now next what we have to do, Q by 4 pi epsilon naught, okay, 4RA by, here we need to write R square A plus R square A, it will be 2, okay, 2R square A square. So plus 2R square A square minus 4R square A square, it will become like, you can see, minus 2R square A square. Next step, again this is in the form of like A square plus B square whole square formula, and this step we will get, how we will get, I will going to show you. 4RA, here it will become like you can write a power 4, not here r power 4, r square minus a square whole square. Why we will get this step means, once we are opening this r square minus a square whole square with the help of a minus b whole square formula, again we will get this step. Okay, so this is our final resultant, like we can say E, that is total charge. I will going to write one more step, and I am clumping this, okay, as like 4q r a by 4, not in numerator, not 4, only we have q, 4 also, 4q r 4 pi epsilon naught, it will be like r square minus a square, and this is like p cap. Now if r is like lesser than a, so r square also very much lesser than a square. So in this case we can ignore a square, here ignore a square. So final step we will get like 4q r a by 4 pi epsilon naught. If we are just skipping this a square means r square into r square, we will get r power 4 here. How we get? Look at here, r square minus a square whole square, r square whole square, because we are ignoring this a term. So r square whole square, it will become r power 4. This step we got, but here this r, this power 4 get cancelled, it will be 3. Then p cap, and we got answer like E is equals to 4q a by 4 pi epsilon naught r cube. Here p cap, here p cap is unit vector along dipole axis from minus q to plus q. So it will finally become like E is equals to 2p by, we got 4 pi epsilon naught r cube. Since here p is nothing but like 2aq p cap, so instead of 2aq p cap we are writing just p. So p is nothing but here dipole moment, here p is nothing but dipole moment. The above equation gives the electric field at a point on the axial line of an electric dipole. This is only the equation for us. So this expression I am just putting on your screen, you can see. Hope you have seen this like expression, question as well as answer, and in between it is given a direct steps. You are not supposed to write the direct step, you need to drive as followed I show you on board. So that's all about our today's session, today's class. In our next session we will going to continue with different topics like inter second year physics. I am Syed Rashid, you are watching Ahlaved High School and Junior College YouTube channel. Thank you.